Hello, welcome to In 5 Minutes. Next topic is characteristics of common emitter. There are two characteristics, as I have told you, input characteristics and output characteristics. How we are drawing the characteristics? On the input side is input voltage x-axis, input current on the y-axis, and keeping output voltage to be constant. Now what happens over here? At the input you have JBE forward bias. When JBE is forward bias, your IB is variation of IB with the increase in VBE is nothing but the input characteristics. Now as your VCE increases, what is your VCE? Collected to emitter voltage. If it is increasing, that means what you are doing, you are increasing the reverse bias. If you are increasing the reverse bias between base and collector, what will do? It will reduce the width of the base. Reduce the width of the base. When the base width decreases, what decreases? IB decreases. So as you increase the value of VCE 0 to 1, 1 to 2 volts, your change in IB, the higher value of IB, the highest value till which IB is reaching, is now decreasing as you increase the value of VCE. This is what you can predict from the input characteristics. It is limited to a lower value and the increase is again slower when you look at when you compare the graph for different values of VCE. Now how we calculate the input resistance Ri is nothing but the slope of the curve keeping the output voltage VCE constant. This is the input characteristics. Now moving to the output characteristic. What you can tell about the output characteristics? Again, how to draw it? Output voltage on x-axis, then output current on the y-axis. This is how you are making the two axes and keeping the input current to be constant. Again, you have three regions. You have active region, you have saturation region, and you have cutoff region. Again, going stepwise to each and every region. First is the active region. Active region means you have junction, base emitter, forward bias, and JBC reverse bias. Now what will happen because of this reverse bias? If your VCE value is at least 0.7 volts, VCE is the reverse biasing of the base collector junction in this case, so it will act in an active mode. What will happen in this mode? As we are increasing VCE, what will happen? IC also increases. So if you increase the value of VCE, you can say if you are increasing the value of VCE, your IC is also increasing. This is how the graph is drawn. Why? You know, it is because of again early effect. Then second case, saturation region. If for a fixed value of IB, take any value of IB, that is when your IB will be fixed, when your base emitter voltage is fixed, right? When you are fixing the value of IB by fixing the value of VBE, and if we are going on decreasing the value of VCE, that means IB is kept constant for a particular value and we are decreasing the value of VCE. What will happen? Your IC is decreasing, right? Now for at a particular value, you call it as VB minus VC, which is nothing but the base collector voltage, right? If it goes positive, that is plus 0.7 volts, it will go somewhere over here, plus 0.7 volts, right? When BBC is positive, what does it imply? It implies that the base collector junction is forward bias. The drift of electrons from base to collector will cease. That means electrons will not drift from base to collector. So when you go on increasing the voltage, that is more forward bias, after 0.7 volts, your IC will eventually become 0 volts, right? So this region over here is called as saturation. Did you get this concept? So when your difference is below 0.7 volts, what will happen? The drifting of electrons from base to collector ceases after some point and the collector current now becomes to 0 volts. Then the last is the cutoff region. Now if we go on decreasing the value of VBE, if we are decreasing the value of VBE, what will happen? It will reduce the diffusion of electrons from emitter to base. If you are decreasing, VBE is nothing but you are decreasing the forward junction base emitter junction ka forward bias voltage you are decreasing. So what it will do? It will provide less number of electrons to the emitter. So what emitter will do? Emitter will provide less number of electrons to the base. Hence recombination of electrons in the base will decrease. What it will decrease? Again it will decrease the value of IC, right? But because of the potential barrier on the reverse bias junction, what it will do, it will pull the electrons from P to N, and it will constitute the collector to emitter reverse leakage current with base open. So you'll get some value of current ICEO even if you are providing VBE value to be 0, that is the majority carrier electrons are almost negligible, you can say 0. In that case, the current is constituted only because of the minority carriers, and it flows because of the potential barrier, and which is written as ICEO. This is in detail characteristics of common emitter configuration.